So we are moving on to the role of the Academy in the automotive industry revolution session. In the first part, we are hosting international innovation centers who will share their insights and perspective. I'm glad to invite Erez to chair this part of the session. Erez is the technological manager of Avatar Consortium. Avatar Consortium is sponsored by the Magnet program of the Israeli Innovation Authority. Thank you.
Thank you. Good afternoon. I'm very glad to have the graveyard shift when everyone is still waiting for the desserts in the balcony and there's 1/3 of the audience. We are hosting here 3 innovation centers. One will be with us in person, but the other 2 will be joining us electronically through the internet. And I would like to introduce him. We have Professor Jyh-Ching Juang from the Department of Electrical Engineering at National Cheng Kung University in Taiwan. And right now it's, I think, 8 or 9 in the evening. And also Mikel Lorente, Director of Technology of AIC Automotive Intelligence Center from Spain, who is here with us. And we welcome him to the stage for the first presentation. And also Branham, who's the Chief Technology Officer and Assistant City Manager, Peachtree Corners. It's a curiosity lab from Georgia. So he is right now 8 o'clock in the morning, I think. So even if we wanted to move this session to another slot, it would be too harsh for them. So we will start with the introduction of each center, and we'll start with Mikel, and then we go to Professor Juang and then Brendan. I give you the stage. Yes.
Should I start with the presentation?
I think, yes.
Okay. Presentation. Good. Hello, everyone. Good afternoon. Thank you for the kind introduction. And thank you also for the opportunity to participate in this workshop. From my side, as we all know, and a lot of discussion is being done during this summit, the automotive sector is going through deep transformation with many challenges ahead. And we talk about technology, we talk about user acceptance, but the human capital is key for this transformation, and it's going to be the main message on my presentation. Thank you. So, actually, 3 main messages. Let me talk about and explain a little bit about who we are, AIC, Automotive Intelligence Center. Also, talk about the importance of education, training, and talent in the automotive sector, and how we are approaching from AIC through AIC Academy and Campus, all the activities that are related to people development, okay? So, first of all, well, AIC, I think the context is important. We are located in the Basque region, the Basque country, north part of Spain. In Europe, you know that Germany is the first vehicle manufacturer. Spain is the second one. And if we look also at 75% of the value of the vehicle really falls on the supply chain. We have a really relevant industrial heritage in the region, in the Basque country. We like to talk about integrality because within a small region, 1 hour southeast, south, north, west, east, 1 hour also, we have the entire value chain available from OEMs to tier 1s, tier 2, and raw materials. But also we talk about extended sector where we have a long heritage also of machine manufacturers, transport and logistics, energy, digital sector also that is very, very relevant. So if I share this picture with you where you can see some of the facts and figures of the automotive sector in the region, with a high density of automotive companies, over 300, very international, with very international footprint, with a 20 billion turnover. 50% of the production is coming from the Basque region at national level, I mean, so you can see there the importance of this figure. And this was basically the ecosystem where AIC was created. So we had a long tradition of collaboration that goes back to 30 years ago. It was the first European cluster association that was created. So it is in that context that in 2006, several companies, along with the Basque Automotive Cluster, they look ahead and they see how we can tackle the challenges of the automotive sector in a different way. So we integrate innovation and collaboration with a market approach. And it's the combination of these how we create a physical ecosystem where we are working on different steps of the innovation process cycle. And I say physical ecosystem is because today we have 30 companies, key tier 1, tier 2 suppliers that they have established their R&D units in the center from 10 different nationalities. Around 1,000 people are working under the same umbrella in a coordinated way. So they have their own agenda in combination with a collaborative agenda. So we created that physical ecosystem, but together with a virtual ecosystem because we are working through projects, okay? That's a little bit the introduction about AIC. As I said before, the importance of human capital is, if we look at the agenda of the automotive industry, there are many different challenges that we are facing in a horizon 2030. A lot is being said today about automated driving, but we have also challenges that are related to electrification with many new models that are being launched from now until 2030 and developing the supply chain. In order to do that, the importance of electronics, so many different challenges. So let's talk about human capital. As part of AIC, we're participating in a European project called DRIVE that was focused on understanding the skills of the human capital that is demanding the industry. And if we look at this simple graph, this Pareto of what are the skills that the industry are demanding, it's no brainer. We are demanding big data, data analysis, experts, software development with a very specific technical knowledge, mechatronics, system integration. Those are the skills, one of the main skills that the automotive industry are demanding. It's a combination really of hard skills and soft skills that are also very important, and I'll be talking about that in a few minutes. If we basically analyze with a little bit more detail this information, and we were able to basically compare what large companies are demanding versus SMEs, small, medium enterprises, we can see some differences. And look at this information that is here on this slide, where if we look at large companies, they are demanding big data, data analysis, software, system integration, a lot of hard skills in that Pareto, very similar to the data that I shared with you before. And if we look at SMEs from an industry point of view, we see some differences. It is require experts with technical knowledge, with a specific manufacturing, with an understanding and knowledge in specific manufacturing processes. But we see after that some soft skills that are needed. And I'm talking about having the skills to innovate, communication, flexibility. So there are certain skills and there are some differences that we see between the specific types of companies, right? For sure, the automotive industry is demanding a change of mindset. Of course, we need product and process and quality engineers, but the approach is a little bit different. It has to be based in a multicultural, it's a multicultural sector where the customers in the center, with a financial vision, with a digital knowledge, yeah, and all these challenges that I was showing you before, electric vehicles, autonomous driving, advanced manufacturing, really require experts and new talent with different set of skills, as you can see here, related to simulation, software, telecommunications, etc. And those new professionals also, they need to change their mindset. Years ago, we've been working mainly in teamwork, putting effort in the level of adaptation to the new jobs, etc. But this is going to be a constant during the next years. So it's really those soft skills that I mentioned before, they are extremely relevant, and the mindset of being also always ready to change, because this sector in general is extremely dynamic, and this is how we see, and maybe we can talk about this later on during the discussion. Let me also go very quickly about this. The source is the European Parliament about the current situation in Europe, population about 446 million inhabitants. And related to the automotive sector, we're talking about 13 million professionals working as a whole. But one of the figures that we see in here is that we are not able to match and to meet all the needs that the automotive sector has in terms of human capital. Roughly, you can see an estimation of 500,000 vacancies in the automotive sector. Now, let's look at the future now to 2030. I know it's close or far away, depending on how we do the analysis, but the situation is not gonna be easier. If you look at the numbers a little bit in terms of human capital related to the automotive sector, even a little bit less, and even a higher amount of unmatched positions in the automotive sector. Yeah. So how do we see that expected scenario in 2030? Of course, fewer active people in the labor market. There are fewer young people studying. And if we look at the average now in Europe, we can see around 35 years old. In 2030, we expect to be even 45 years old in terms of average. Hiring will become more difficult and expensive, so there's no room for failure. If we look at how fast the automotive industry is evolving, the organizations have to be more agile, finding those new profiles. Yeah. One of the figures that I wanted to show you here also is that if we look at 2030, that 60% of the new skills that will be needed are even unknown, that still are not defined, okay? And the way we see it is that never before, investing in training and in education has been so important in order to make those challenges that we have ahead, and that within the organizations, training and education should be part of their strategy in order to meet those goals. So very briefly, in AIC, from the very beginning of launching the Automotive Intelligence Center, we've been from what we call AIC Academy and Campus, have an integral approach. We have a combination of formal and non-formal education. We have master degrees in automotive. We have very specific advanced programs related to electrification, artificial intelligence, but the approach is a little bit different. We integrate through specific programs, through challenges that might take 6, 9, 1 year, specific challenges where they have to design, to simulate, to prototype, and to integrate in specific platforms. And this is done with a specific task force of new talent, together with teams that come from the industry, working together through a specific project and bringing that. And so there are different goals in this project, and is to learn about certain innovation, to develop new skills, and those people that are working on on these projects that are able at the end of the program to start with a new knowledge in the companies. So many different programs that are happening at the same time, and this is one of the examples, and maybe again during the discussion we can talk about that later on. I talk about AIC Campus as well, so we have a very comprehensive approach, almost like a soccer player that starts very early, playing football, understanding the automotive industry, trying to communicate on those earlier stages, 8 to 12, where they sort of like designed in their brains what they want to do, what they like, at least what they don't like, and so to try to, through challenges, to bring some programs. As I mentioned before, Open Universities, the concept of bringing together the industry along with the academy, universities through projects, and also we have specific programs that are focused on the industry, developing programs in company and on site in our premises. Just to wrap up, a few conclusions. As I said before, developing those new capabilities and knowledge it is in strategic areas is crucial. We need to accelerate the innovation cycle, coordinating closer and closer and bridging that gap between the industry and universities. We need to generate the high potential talent and leadership capacity, talking about soft skills that I mentioned before. And we need to break the gender barriers also, attracting young people to the sector. No brainer that at the end of the day we are competing with other sectors. So we have to properly communicate the challenges and the opportunity from a professional and personal point of view, capacity that the new talent might have. And this is all from my side. You have here my coordinates in case you need further information. You can contact me later on. Thank you for your attention. Looking forward to discussing later on. Thank you.
Thank you very much. Our next guest, our next presenter will be Professor Juang from Taiwan. Can you upload his Zoom?
I would like to share with you something related. That means sensing for autonomous vehicle. But I'm from Taiwan, so I would like to share some activity that's carried out in this part of the world, which is in the Pacific Ocean. And first of all, thank you for the invitation. And my presentation will be about the activity, and definitely I will also talk about the build-up of human capital. Okay. I'm Jyh-Ching. Okay. And I think this mega trend is all we realize. That means the combination of autonomous driving, electric vehicle, as well as a connected vehicle, and also for sharing services. And a lot of potential as we can benefit, as we can realize for public and also for personal mobility. And I think this important forum or the important workshop is target for smart mobility. And definitely we try to realize all this kind of benefits, which including the enhancement of safety, improvement of efficiency, and also even for environmental more friendly. And this kind of vision definitely is shared in Taiwan. So we also realize this trend. But one thing that's missing in Taiwan is we do not have automobile industry, because almost all our vehicles are imported from international. So we do not have a local automotive industry. But as this ACES trend, that means autonomous, electrical, connected, and shared trend, those are related to a lot of information and communication technology. And therefore, that we also realize it's important to get engaged in this industry and also try to have certain talent training, okay? And in Taiwan, we try to look for two perspectives. One is try to develop certain enabling this technology, and that's from the technology build-up. And also we try to facilitate this kind of service because this will realize all the benefits as mentioned. And to do this, the government have formed a harmonized approach through a multi-period approach. And in this diagram, you can see different departments of the government are involved in, to pushing forward for this kind of realization of the benefit of autonomous and also electrical vehicle. And there's a planning parts, and there's also some registration and deployment part, because that's related to the regulation for the transportation. And as this kind of autonomous driving are related to the data, and one important data is the map or the digital infrastructure, and or more specifically, this kind of, we call it high definition map. So Ministerial Interior Affairs that are related to this kind of build up, this kind of data infrastructure. And also the industry is getting involved, and the Ministry of Economic Affairs. So they try to set up certain programs to facilitate the industry to get involved. And the one that are more related is the technology part. That means the Ministry of Science and Technology are involved in the building of the innovative technology. And I'm also related to training. That's the responsibility of Ministry of Education. And so in that case, that we form certain training program, try to, for example, reshape the curriculum, and hopefully that we can come up with certain courses or courseware that's more relevant. So with this, definitely a lot of activity going on. And I would like to mention the Ministry of Science and Technology, because under this, a lot of research institute and academic involved. And one particular organization that I'm associated with is the National Applied Research Lab, because under this lab that we set up certain test site or closed field test proving ground, try to facilitate and do the test of all this kind of autonomous driving vehicle. And we hope that through this kind of coherent or harmonized approach, certain innovative technology can be developed and system integration will be emphasized, and lots of data analytics can then be utilized in the proving ground, and also hopefully that can set up a infrastructure for the ecosystem, and then come with certain business model as well as mobility as a service kind of related activity. And the NALab is responsible for the Taiwan car lab. The car stands for connected and also for autonomous and load test. So this is a test site or the closed-field test site that target for the test of connected and autonomous vehicle. And it's located in Thailand. And the roadmap is as follows. That's we try to build a certain simulation. Hopefully that we can test in our facility, as well as some cross-track testing. And these are some representative track in Taiwan street and those. And with this kind of accumulation of knowledge, as well as certain test facility, we hope to test the autonomous driving vehicle in the proving ground, and afterward we can have certain permit to go to the public road or the on-road test. So we try to form this kind of test infrastructure, and with that we will hope to also test database, and this kind of database may be unique in this part of the world, and then definitely we will hope and we will have to share this kind of information. And to go to the public road, definitely that we adopt or we follow the approach that's also carried out in the United States. That we come up with certain regulatory sandbox. So different organizations or different companies, they could apply for a certain approval to go on the public road to do a test. And this is a free Taiwanese tag, the map, and then you can see different kind of size of vehicle from the buses, and also 7 different cars that are doing the test on the street. Okay, and I share with you one video that's is related to this kind of activity. And this video shows the test site as well as some tests that's being conducted. And it's prepared by the Ministry of Economic Affairs. The vehicle, by the way, is owned by the university that I belong with. Okay. Okay, with that, the government effort and the university effort, and definitely the local industry, they are paying attention to this smart mobility. And as is a combination of smart vehicle, intelligent road, as well as some secure connection, and also service-oriented thinking. And for that, as you know, that Taiwanese have a lot of strong background in information and communication technology and semiconductor technology. So a lot of companies, they are getting into this business, and hopefully they try to form certain alliance, try to get involved in this kind of business. And one representative alliance is an alliance formed by Foxconn, which is known to manufacture lots of iPhone. And they try to using existing establishment in semiconductor information and computer technology, and from this kind of from an electrical vehicle supply chain, and they particularly emphasize the so-called software-defined vehicle, because they try to differentiate the market penetration with other existing build-up. Okay. And to do that, from the education side, which I'm responsible for, that we are developing certain talent incubation program for autonomous driving and autonomous vehicle. And for that, we develop certain educational module, which needs to have certain integration and certain hands-on related to that. And we also emphasize on simulation and verification. And I share with you one of the videos that we are developing. Sorry for some of the Chinese character, but from the video, you can see what we intend to do. Essentially, we try to develop a cyber-physical system, and in the diagram, you can see the cyber world that's on the left, and the physical world on the right. So that's mean from the camera, you can see what's going on outside, and also we have a simulated environment, could also simulate the environment. And on top of this diagram, those are the two software that are running. One is in the cyber world, that's in the computer simulation, and another in the real vehicle. So this software is running on the real vehicle. So we could then, based on this, and then, for example, verify the simulator to show that you have sufficient fidelity, and also develop a certain software, so we can test the software in the cyber world or simulated world, and also do that in the real world. And this software is open publicly. So that's, if you are interested, definitely you can contact me and we could hopefully share this kind of information. So as you can see, this is a real vehicle that's engaged in this kind of software, and then we can also test it with a certain sensor information and do all this. So as a summary, we believe that smart mobility is a mega trend, and so a lot of activity going on. And so this workshop about smart mobility definitely is a very important one. And Taiwan is prepared for this paradigm shift. So we develop a cross-track test site, and also we encourage open load tests. And to do that, I think we involve a lot of industry, and we also regard the incubation of human resources is important. And with that, and definitely we welcome all the cooperation, and I look forward to the discussion. With that, I thank you for your attention.
Thank you very much, Professor Juang. Our third speaker will be Brandon from Georgia. The floor is yours.
Thank you for joining us today. A little bit about Peachtree Corners. We're a community outside of Atlanta, so southeast in Georgia. We're about 45,000 people, but uniquely positioned. We also have 45,000 jobs. So we are a regional job base for the Metro Atlanta area. We have companies such as Siemens and Navient, Corsair, close to the airport, so easy travel in and out. And what's unique is 45,000 jobs, but only 3% of our population actually lives and works here. So 97% of our employees on a day-to-day basis are driving in from the surrounding area. So that makes mobility a very important topic here and how we do that. So as we think about what the future of autonomy and connected vehicles looks like, we looked at what can local government do to bridge that gap. How can we play a role in facilitating this innovation so that we can move people around more efficiently and obviously more safe? So that's what led us to develop what we call Curiosity Lab at Peachtree Corners. And when I say that, it's really an environment. It is four things. We have a 3-mile advanced vehicle, autonomous vehicle testing facility that is on a public road. So it's not a closed course. We do not control the variables that us as humans bring to the environment that we drive in. I'll show a picture here in a little bit of what the setup looks like, but it is a public street that we allow for autonomous and advanced vehicle testing to go on. We have a mobility test platform that's available for companies to come and use to test their equipment. We actually have an Israeli company you might see there at the conference, Broadband 17. They have their technology on this vehicle doing testing now. And then we have the city street of the future. We have fiber connectivity, 5G with our partner in T-Mobile, all live here for companies to take advantage of to test and demonstrate. And then we also have a 25,000 square foot innovation center that serves as the operating hub for our operations, where T-Mobile has full-time staff, as well as UPS is here inside of our space. So this is a picture of the roadway itself. So it's inside a 500-acre office park. As you can see, we have the outside lanes dedicated for the advanced autonomous vehicle testing. We really see ourselves as the walk phase of the crawl, walk, run. So you can use as Dr. Juang saw, they have the closed lab, go there, test it, but maybe you're not quite ready for downtown Tel Aviv. So you can come here where there is still that interaction with the human-driven population and pedestrians and cyclists in micro-mobility interfacing with autonomous and advanced vehicles, but in a little less controlled environment, about 5,000 to 7,000 cars a day traverse on the roadway. And then all of the infrastructure is connected either through fiber or 5G. Some of the outcomes of what's happened, we've been open for about 2 years. We currently have 4 autonomous last mile shuttles deployed here, Local Motors and Navia, the French automaker here testing connected vehicle implications and real world interactions. As you can see in these pictures, the shuttles are right next to the vehicles that are traversing on the roadway, so they're gaining valuable data from that. The roadway is not flat. There's a 14% grade change, mature tree canopy, as you see. So dealing with all those environments, as we have seasons here, so the leaves fall on the ground, cover up the roadways, all those things that we had to figure out as we advance autonomous driving. As we know, some of the steps to get there is teleoperation. So here's an example of a company that used our facility for teleoperation. This is Phantom Auto. They were here demonstrating for the logistics company. The guy in the middle that you see there sitting out in California in Silicon Valley, driving the vehicle here in Peachtree Corners. This goes all the way down to micromobility. So here we have a teleoperated e-scooter. I've been to Tel Aviv, which I was there now with you all, and have ridden the scooters around Tel Aviv. The clutter is a big issue where you see them scattered along the roadways and sidewalks. This company is trying to see if they can fix that, and they use teleoperation to reposition the scooters after a rider is done. So they'll move the scooter to the next rider or to a central docking station. They were able to take this product here, tested for a year, and signed an exclusive deal with Spin, which is Ford's e-scooter provider, and they're launching 300 of these in Boise, Idaho. So a great example of using the real-world testing facility to scale a product. So as we think about, from the government perspective and the private sector, what's that next step to help autonomous and advanced vehicles really traverse in roadways using the infrastructure? And that is cellular V2X. And so it's communication from vehicle to vehicle, vehicle to infrastructure, and vehicle to pedestrians to move vehicles safely and efficient throughout the streets, protecting the vulnerable users as we do this. We're partnered here with Qualcomm, testing cellular V2X here on the public street. So we're actually doing vehicle to vehicle with the autonomous shuttles and the city fleet, as well as connected into our infrastructure. So some of the applications of CV2X from a network mode is weather conditions being reported live over the air, traffic guidance for the vehicles, and then emergency notifications that if there's an object in the road, this message can be sent to the vehicles ahead of time so that they're aware before they get there. At the intersection, moving cars, as we all struggle with and sit in traffic, how can we make our intersections more effective? Cellular V2X is one of those that's being tested here, setting the signal phasing timing to the vehicle so it knows whether to slow down or speed up to go through the light. Get ready for green. Most of us are distracted drivers. When we pull to a red light, how many of you pull out your cell phone to look at it while you're waiting on the light? So that slows traffic production through the signal. So we have a company testing a get ready for green. It alerts the driver when that light is about 5 seconds from turning green so that they can look up and drive through the signal. You can also get into preemption through cellular V2X for our emergency vehicles or our alternative vehicles like the autonomous shuttles. Most importantly, one of my projects that are dear to me is the protection of our pedestrians as they go through non-signalized intersections or crossings, as you see here on the left. This is what's called a rapid flashing beacon. So pedestrian pushes the button, it actuates the lights to let the vehicles know that there's a pedestrian getting ready to cross a crosswalk. We've connected this with a roadside unit over CV2X, and now, as you can see in the picture, that is a hill, so it can alert the vehicle above the hill about 500 yards away that button has been actuated, so there's a pedestrian ahead, so giving extra caution to our pedestrians as they move around. So of all of that, I know most of you are in the mobility space or connectivity space in some form or fashion. So if you leave from anything from this presentation, we have an environment here that is for use. We already have a lot of relationships with Israeli companies that have taken advantage of the infrastructure that we have here. Over $5 million worth of infrastructure that's here to use. 7 points to walk away with. We are a live 5G environment. both on millimeter wave and 2.5 bands for testing. That's free to use. The roadway infrastructure is owned by the city of Peachtree Corners, so it's a very quick approval process to get you onboarded and taking use of all the infrastructure. Most importantly, we do not charge for the use of the infrastructure. It's not a pay-to-play. We do this out of the activity and the growth of this industry to be able to take advantage of public sector infrastructure. We do not collect any IP, so anything you invent here is yours to keep and continue to use and grow. We've set the networks up in a way that we can respect and guarantee the security of your data. So when you're here and you need to keep that data secure and private, we can do that. We also achieved NIST 171 compliance, and here in the States, that's the highest level of data security you can obtain for unclassified data. We want to ensure that companies know when they're here, their data is being taken serious and secure. I actually partner with two cybersecurity companies from Israel, Dynamics and Cyber 2.0. And then last but not least, we also carry general liability insurance for driven vehicles like every municipality, but we also have it for driverless vehicles. So if you're here testing autonomous vehicles, the roadway is insured for that. All of this, of course, cannot happen without several of our partners. Some of these you may know, the Ciscos and the Bosch and the T-Mobiles of the world. But we have an arrangement of several partners who help facilitate this innovation. In our international partnerships, as you see, some of those probably look very familiar to you. We understand the importance of making sure that the lab is used to help companies as they enter the North American market to make that entry as cost effective as possible to help them scale. So that is Curiosity Lab, and I thank you for your time today and hope you have the best in the conference.
So now we are at more interesting question and answers. That's questions that I asked and you will answer. And I think previous panels discussed this problem of finding adequate people today when everything is so competitive and every industry and every sector is competing for the same kind of people, data scientists, AI people, neural networks. And I will start with an anecdote that I was in a different capacity. I was auditing a company, and they needed to hire an AI guy, a data scientist. And we asked, so are you hiring? They say, yes, we had one guy yesterday. So I asked the CEO, so did you interview him? And he said, Erez, you got it all wrong. He interviewed me. So in this landscape, we need to know how to attract the people to the automotive industry, and would like to hear from you, from your experience, what is the best method or way to attract people, and just give them more money, I think is not the correct answer, even though someone said it before, because everyone eventually are going to be about the same salary level, but still there are more appealing things in this industry that can approach young people. So we'll start with you, Mikel.
Hello? Okay. Yeah, I think we talked a little bit about that. I think there are three different levels. One is the effort that we have to do to share with a pool of talent coming from the data science and software world about the opportunities that the automotive industry is bringing. The communicating part is key. The automotive industry has been over the last years going through different type of transformations, but the landscape today it is huge, and I think also through this communication is the fact that there's a career opportunity and the opportunity also to work in a system integration concept where the combination of different views and angles from the data analytics together with system integration, electronics, electric architecture, the challenges of working in a team environment, and not only that, we're speaking about a sector that is global. So we talk about NAFTA, we talk about Europe, we talk about Asia Pacific. The opportunities to grow a career in a multicultural approach, they are huge. That would be number one, to try to share the ambition and the moment where the automotive industry is today. The second one is to hire the right talent. The right talent with the right skills to fit in within the organizations. So it's a combination of hard and soft skills. If we want to retain, which is the third level, retaining the talent with that career path and opportunity, it is a challenging sector. Where if we look at the, I don't want to talk about economics, but it's extremely tight. So the level of requirements is extremely high, and that person that needs to have some specific willing to work in a sector that is very competitive. And so what I'm trying to say is that once you go through that screening, the opportunity is there, but not everyone is going to fit within the automotive sector. That is a fact. It has to know the opportunities, the challenges, but it's a tough sector.
Thank you. Professor Juang, do you find also these challenges in hiring or finding the right personnel for your initiative?
Yes, this is indeed a very big challenge to hiring this kind of professional, because you need a lot of knowledge, software, hardware, and mechanics and electrical engineering, as well as you need to have a system integration or system engineering kind of concept. So indeed, a company is very difficult to hire the right people, but also in Taiwan, we are facing a little bit different issue. That means we do not have automotive industry. And that's the sad side. That means the people, when they get into this kind of career, they just wonder what's the end point are, okay? But luckily, some companies, they are doing well in the way they try to convince the people, because as you can imagine, lots of semiconductor IC manufacturer companies, they try to develop this kind of module as well as the ICs that can be utilized in the smart mobility kind of vehicle. So that's why we got this kind of training to try to looking for the information and computer scientists. So we just look at vehicle as one of particular application, just like a mobile phone is just one of particular application of the semiconductor and IC design. So we try to push from that side. Hopefully that people, they learning AI, learning 5G and all this, they realize that vehicle is just one of particular application. So they can have a good career if they can get involved in this kind of the business. That's a way that we try to convince the young generation to get involved. Okay, so that's my comment.
Thank you, Professor. Brandon, in the United States, do you see also the same challenges in recruiting the right personnel?
We do. As we all traditionally know, in the U.S., it's been more professional services orientated in our education. So we're just starting to really start to swing that pendulum to increase activity in the STEM, science, technology, engineering, and math. And we're taking that approach by integrating that into the early stages. So in our high school arenas, we're building those programs. We work directly with high school students to get them integrated into these technologies so that the choice for when they go to higher education, maybe those ideas have already started and they're culminating with that. And then we work with our universities to get them engaged in these applications the best we can through our partnerships and our facilities here, because we know that in order to meet the demand that's coming in this area, you're going to need all levels. From system engineers and integrators, as both our colleagues here said, but also how do we repair these vehicles when an autonomous vehicle breaks down? Are we going to have the skill set to be able to repair that? And we're working with one of our local technical colleges to build that program, which would be the first in the country here in the U.S.
Thank you very much. The next topic for questions will be about what you specialize in, which is innovation. And what we see in Avatar Consortium is that there's a big difference between academic benchmarks and actual real life or street level performance. So many companies say that they beat the best benchmark, and still the performance in street level is less than what the academia is performing on sterile benchmarks. So I think that you guys at the Innovation Center see that all the time, and I would like to hear your take about the difference between what is considered to be the scientific benchmark and the real life performance.
I think it's a good question, but I think we're talking about two different worlds. One is the academic world with their own KPIs, with the mission and the vision, and I think that is fine. And then we have the industry, and the performance really comes from how they are delivering in the market in terms of sales, in terms of profit, in terms of many other elements in our organization. I think most importantly is how we can bridge the gap between the new talent and what the industry demands, and how we can develop new programs to develop new skills. But that takes time. The speed to develop a new program could be 4 years, and then you have new talent that require another 4 years. It's a long process. However, we can bridge the gap, specializing programs, combining different programs, developing new programs to bridge that gap. So to me, I mean, you can benchmark the academy world, the industry world, but there are two different worlds. It's more about how you can close the gap and work together.
Professor?
Go ahead, Professor.
Okay, so I agree that's a two different world. And just like when we are doing AI or deep learning, we have a training stage and also a verification or inference stage. So that's mean in the academic world, we are more or less in the training stage. So we can push for performance, push for benchmark, and then try to write a paper that's out, to outperform others in terms of some metrics that's been defined. But in the industry, that we are looking things differently, because there are so many different corner cases and the combination of all this. So you try to ensure that the vehicle is safe and then will not make mistake. So that's a different world. So therefore, that we try to encourage our students that when they do this kind of, for example, AI, they had to be aware that the training, or even you had to think about something that's thinkable. So that's we try to push from that side. And I agree that it's indeed two different kind of world, two different kind of problem. Okay? Thank you.
I think that's a great question, because I think a lot of us tend to think that way, that we see things being tested out in academia and then they're ready for the real world, but they are two different missions and objectives. But I think we can do a better job of using them together, helping one help the other. But what we see here in the real world application, it's always going to be safety first for a lot of the operators. And then how do we get it to scale it once we can break those down into an area where adoption of these technologies are really what's going to drive this. And I think that's where we see ourselves in getting these figured out. How can we actually make them where a user wants to go and take that versus their personal vehicle versus, or a non-traditional type of public transit. And I think it can be using both of them together how we do that, but they do have two different objectives.
Thank you very much. My next question will be also about innovation. We witnessed this past decade a huge leap in perception technology when neural networks became actually feasible and can run right now on a regular computer or graphic card. And we saw in all the Pascal and all the competitions a huge leap from 25, 30% of perception capability, and now we're reaching to the 95. And every time I see something very innovative, I can see that someone is doing 1% more or 2% more. And what, as managers in innovation center, where do you see the next big leap? Or how do you define innovation when you see it that is comes to a problem and just pushing it few more percents up? How do you define it?
Yeah, well, it is true that in any evolution, you have, at the beginning of that evolution, you have a change with a bigger slope, and then you have an asymptote. And moving through that asymptote is more difficult. It's becoming more and more difficult to really find a differentiation between one strategy and another. But I think the landscape 10 years ago was a little bit more different, 10, 15 years ago, where collaboration was kind of like a weird term that it was easy to put it in a PowerPoint presentation, but it was difficult to bring that into a reality. Situation now is that we're talking about the smart mobility. We are speaking about such the level of complexity is so high that more than ever collaboration between different stakeholders become key, and how we can bring value working together. Now, when we put also different stakeholders around one table, it takes time. Just think about electrification and finding the right infrastructure for electrification to plug in electric vehicles. Now we're talking about automated driving. We are now on the verge of going from level 2 to level 3. We are more or less 2.5. So the level of complexity of bringing that into the market is very high. Because one thing is technology, but then we have regulatory framework, and then we have user acceptance from a cost point of view. We cannot think in terms of having always huge incremental changes in innovation. I think the impact of even moving through the asymptote are also very big. So that 0.5% in a more complex landscape has the same impact to me that 10 years ago when we're making changes with probably a more incremental change. That would be my approach. Yeah.
Professor?
Okay, I would like to add to that, and by pointing out that we really had to look into the application. For example, you mentioned Pascal or this kind of certain data sets to have certain recognition or classification. But in the smart mobility world, we really had to also look into different locations. That's a different part of the world. They had different kind of patterns. They had different kind of setup. So therefore, that if you want to do the transfer learning, you may be subject to a lot of difficulty. So that means the dimension we had to look at is not only for the innovation in the neural network, rather we had to think about how good we are able to adapt to different kind of situation. And I think that's maybe a key for future smart vehicle. That's mean how good you are to adapt to your environment, and the environment can be changed. So that we may need certain fundamental change in our network, or even to add something that's to in existing network. So that's not to increase its performance, rather to include its resistance to the environmental change. So that's my comment.
Brandon?
Yeah. Yeah, I'll leave the academia session of this to my colleagues here because that is definitely their wheelhouse. But from a practical standpoint, right, defining innovation is, does it take what we built upon and make a significant enough change to automate or enhance our day-to-day lives? From public sector, can we automate traffic management? Can we automate our public transit services? How we get there is going to vary. I do agree with that. The steps do change. We did make a big leap, and now we're figuring out how do we build off of that. And I think it's going to be a little slower than most of us probably want, but I think we're headed in the right direction with it.
Okay, thank you very much. Are there any questions from the audience?
Hi, my name is Negev and I am the radar general manager of Mobileye and Intel. My question is, you're looking into AI and machine learning based solutions for solving the radar perception. While you both mentioned that there are some risks, that in different scenes, this will not be sufficient because of what you've trained the system to do. And therefore, you know, in this industry, we are talking about ODDs, right? And we're trying to fence the risk according to the operation domain. So what the car will be able to doing and what it will not do. And the question is, when you're looking into ODD, and you still want to raise the ODD on one hand, and you want to use ML or AI, what would you do in order to fence the risk that you're taking whatever is needed, that the algorithms will be able pushing the vehicle to support many different scenes, but still you will not need to train it all the way. Because training that all the way is probably impossible to go and train for all of the scenes. The question is, what are we doing in between? If we will find how to break this paradigm, I would say, we'll find a solution for how to do it based on AI.
Let my colleagues to answer first, and then I'll go.
Okay, I'll comment first. And definitely, AI cannot solve everything. It's a part of the, just like it's part of a weapon that we can use to enhance the safety and also the efficiency. So in the smart mobility, we talk about certain unknown and known situation. We talk about safe and unsafe situation. So maybe we can look at, I think here for mobile app, and definitely, this kind of sortive and safety first kind of concept. So maybe when we try to look in ODD, definitely we can then try to have a clear definition of ODD. And also we should be trained to be awareness we are getting to the boundary, and perhaps we can set a certain bottom line there. And with that, we can at least ensure the safety, and then we're looking for see what we can improve afterward. Okay?
I'll defer to our colleague.
Brandon, do you have any thoughts about that?
I don't disagree that AI can't solve everything because we can't recreate everything that's going to take place in our real world. It's going to, I think, going to lean more towards the ML piece because we're going to have to react to the environment that constantly changes, right? We're all unpredictable in our nature and how we do and how we move about in the world. So it's got to be a combination of continued growth between ML and then supplementing with AI for what we can.
Thank you, Mikel.
Just from just to get a different angle, rather than technical, is more about market acceptance and deploying level 2, level 3, level 4. How is this going to happen over the years to come? And really, the transition between 2 and 3 has a big impact as how to do that transition. So it has to be done safely. So there are certain environments where, with less complexity, talking about auto vans, about specific areas where that transition can be done safely. Now, let's think about a big city in India, for example. I don't know if we're going to see that coming in the years to come, because the level of complexity in those environments is such a step up. So I think we need to be very careful as how together we bring that into the market, keeping in mind the user acceptance. And with that, I'm not saying that we should not be ambitious. We have to be ambitious, but we have to move carefully as how to do that. I'm moving to level 3 with certain speed limit, for example, and in certain areas, etc., just as an example, because AI won't be able to solve everything. And the social impact that we might have, but going too quickly, I think it's going to have a negative, negative feedback. So we need to be very careful with that.
Okay, thank you very much. I think we're out of time, so I want to call Igal. I think you're the next speaker. Igal or Tchiya? Okay, so Tchiya.
Thank you, Erez, and thank you to all speakers. And now we are moving to the academic perspective about the role of the academy in the automotive industry revolution. And for this session, I would like to invite Igal to chair the session.
Thank you. Okay, so first of all, I would like to invite Professor Joseph Tabrikian from Ben-Gurion University as a professor and the founder of the School of Electrical Engineering, give his perspective on academic role and industrial role in sensing for autonomous driving.
Thank you, Igal. Okay, I will talk about AV sensing challenges. There are two main AV sensing systems. One family is cameras and lidars. They provide good spatial resolution, but they are sensitive to weather conditions and lighting. On the other hand, radars are insensitive to weather and lighting conditions, but they can provide a very good range, high accuracy range and range rate information. The problem is that they suffer from low spatial resolution. However, in the recent years, due to progress in radar technologies such as massive MIMO or cognitive radar, we are able to obtain LiDAR competitive performance in resolution. So I will talk mainly on radar systems when I talk about AV sensing, because in my view, it's going to be the future technology. The main knowledge centers of radar systems before the last decade were in two places. One was in military-oriented industries, and another one, a few research centers and labs in universities. However, military application scenarios are completely different than automotive environments. For example, clutter example. In military applications, clutter is some undesired echoes which needs to be suppressed. In automotive environment, actually, we don't have really clutter. Clutter is, for example, the road or sidewalks. They are actually targets of interest, and we would like to localize them and detect them. They are, of course, distributed, and it adds some more difficulty, but they are not. We would not like to suppress them. So this requires rethinking of radar objectives and basic models and assumptions, and new theories need to be developed. In addition, many companies, as we heard today, many companies which have been established in the recent decade on AV sensing, they require skilled engineers. And in fact, the AV sensing revolution that we are witnessing now is very similar to what we witnessed, what we had in communications during the 20 years between 1990 to 2010. And the question is whether the universities can play an active role in this revolution. I will talk about shortly about some challenges automotive radars. For example, we encounter near-field scenarios. Near-field scenarios. Most of the literature in radar signal processing focused on far field, and in automotive radar we have near-field scenarios. In addition, we have resolution challenges and distributed targets. For example, here we need to know, we have this bridge, and we need to know that we can pass through this bridge, so we need some resolution, and we have here these distributed targets, and here we have also distributed targets, and these are the echoes of these targets. So resolution is very important here. Another problem is multipath. Here is a situation of a horizontal multipath. This is the host vehicle and the target vehicle. This is the direct path and the indirect path, and actually we see ghost vehicles due to the indirect path or reflected paths. In vertical multipath, we have the direct path and the indirect path, which is reflected from the road. This kind of multipath, for example, is different than this one. Here we mainly encounter fading. This problem, for example, can be mitigated by frequency hopping. Another challenge is time-varying environment. When the vehicle moves, the environment changes. So in military applications, this problem was addressed by space-time adaptive processing, for example, in airborne radars. Here we need to adopt similar techniques, but of course the application will be different. Also, cognitive solutions. When the vehicle moves, it doesn't make sense to transmit the same signal for all scenarios, for all cases. So in the recent years, there are many works on cognitive solution. Here, for example, we have here the environment. This is the transmit signal. This is the receive signal. We usually use this block in order to detect, localize, or classify the targets. But in cognitive solutions, we try to use the receive signal in order to decide what to be transmitted in the next scenario based on previous measurements and actually using cognition. Another last example, here we have two different targets and we have multiple echoes from each one of these targets. We need to identify which echoes are related to each target. Of course, this is a very difficult problem, and we can use tracking and tracking association in order to solve this problem. These problems were not in military applications, and here we have a lot of challenges to address. So I will talk now about the academic role in general, and then focus on AV sensing. In fact, in academy, we have three main objectives or roles. One is research, education, and contribution to community. So in research, we develop new theories and knowledge. And for AV sensing, actually, we need to steer this research towards the automotive industry. Also, time is very important here, because in academy, usually we do research without any time constraints. Here, the time is the industry changes moves very fast, and the time is very important, and we need to shorten the time from idea to proof of concept. In education, we usually produce engineers equipped with self-training capabilities. But in this specific case, we need special courses and labs and training via engineering projects, undergraduate, for example. In contribution to community, we have actually two main roles here. One is knowledge transfer, the knowledge that we have developed in academy to industry via some joint projects. And another one is distribution of this knowledge via some scientific and technological meeting and symposia. And what is, I would like to discuss about research. We need to talk about efficient development of knowledge. For this purpose, we need to know what are the components of knowledge. The components of knowledge, first is know what, which is learning the facts via some experiments. Know why, which is understanding the science behind these facts. And know how, which is finally developing the new technologies. In this table, I show what, in my view, the strength of industry and academy. For example, the industry is very good in know what and also in know how, but they are less interested in know why, understanding the science behind the facts. While in the academy, we are interested in know why mainly. And of course, if the research is appropriately steered, we can also produce the know-how very efficiently. So this actually motivates the academia and industry collaboration in order to produce solid knowledge and technology. Current platforms of promoting the research in academia is bilateral projects via Magneton or some direct industry academy projects or consultancy. These are done not bad. Multilateral projects via consortia like Avatar, as we heard. And support graduate students' research. For example, there are already some existing grants for students by ISTRC. Of course, this needs to be further enhanced. Some proposed platforms is funding basic research via periodical grants. For example, there's Ministry of Science and Technology or MAFAT or PASI Foundation. They provide periodic call for proposals for research, and they fund research in an annual basis, and this needs to be done also for automotive industry or automotive sensing. Another point that is proposed here is establishing research centers for AV sensing topics. Currently, the research is performed in different universities and not centralized. In education, we need new courses and labs. For example, if we compare in communications, this is the revolution that we had 30 years ago. We have in all universities track specialization in undergraduate studies, and we have, of course, several undergraduate courses and laboratories. In radar systems, we almost don't have, actually we don't have any specialization track, and usually in most universities we have one or two elective courses, so this needs to be adopted and enhanced. So how can the industry help in these efforts? One is proposing topics for syllabi definition. Actually, the industry knows much better than academia what are the needs and what topics needs to be defined. Another thing is support by financial support for new courses and mainly laboratories which need the equipment. Also proposing lectures for academic courses. Again, there is a lot of knowledge in the industry and it can be also brought to academia. And also seminar talks at the universities. In undergraduate projects, we can promote for this topic, for example, by proposing AV sensing related topics for undergraduate engineering projects, and also awards for excellent projects in order to encourage, this I mean here for undergraduate engineering projects, in order to encourage AV sensing related projects. So in terms of contribution to community, one is the joint industry and academic projects. For this purpose, we need, the industry actually needs to identify the relevant research groups. And also there are some IP issues which needs to be solved. So these are two problems which need to be addressed. In terms of distribution of the knowledge, academia can conduct some annual symposia on AV sensing topics. This, of course, involves some financial projects. This can be done, again, by those research centers, as I mentioned earlier. Also, there can be some weekly or monthly webinars by internationally recognized experts. Again, people from academia can do this very efficiently. In summary, addressing AV sensing challenges requires massive research efforts, as I described just a few examples. Academic researchers are able to lead such research efforts, but their research needs to be motivated and steered via government authorities, like Innovation Authority or Ministry of Science and Technology or ISTRC. Existing platform for industry academy collaboration exist, but they are limited and they need to be enhanced. Some suggested platforms for promoting AV sensing. The first one is establish AV sensing research centers, which can promote several issues. Support graduate student stipends. Conduct joint research with industry partners. Conduct annual symposia. Again, this can be done by these research centers, and conduct weekly or monthly webinars. That's it. Thank you. Yes, please.
A few slides ago, you mentioned that the industry has the smallest know-how. And 2 slides ago, you mentioned that you want several courses industry will provide the academy. So my question is not at all related to AV, but does the industry know how to provide courses to the academy? Does your people, which are all fine people in AV, know how to provide a course, know what to teach, know how to teach even? Or do you expect the academy to I don't know, bring their own people to you and learn, and I don't know, some kind of collaboration and make a course? Just because I don't understand how this...
You refer to this table?
Yeah.
Yeah, okay.
That the know-how. But my question is for what you are willing to provide or need from the academy. You want to take a course in AV or something. So do you know how to do it, or do you expect the academy to do it for you and you give the knowledge, or how is this combination going to work?
In academia, we have actually the basic knowledge, but some specific goals need to be defined by industry. For example, I give some consultancy to several companies, and I have a lot of knowledge, but my knowledge needs to be steered to specific directions which are defined by those companies. Without those companies, I cannot steer my research, my knowledge. The same about the courses. Okay? Okay. Thank you.
Okay, our next speaker is Professor Shiller from Ariel University. He will give us his view on the same topics. Please.
Thank you. Okay, how it works. Oh, good. Okay, thank you very much. First of all, I want to thank Tchiya, Kati, and Igal for organizing this session. Wouldn't be another better opportunity to actually speak about what we want to do, to say. My talk is a little bit less deep than the previous talk, and we overlap. So, I apologize for that. So I'm Shiller. I'm the head of the, first of all, I'm the chair of the Department of Mechanical Engineering and Mechatronics at Ariel University, where we do teach also robotics, which is very connected to autonomous vehicles. I'm also the head of the Laboratory for Robotics and Autonomous Vehicles. And I've been here, I'm just celebrating 20 years since I returned to Israel, just exactly 20 years ago in October 2001. Thank you very much. And not surprisingly, we are going to speak about autonomous vehicles, autonomous driving, right? Okay. So let's start from the top. We just participated in an international competition of autonomous race cars called the Indy Autonomous Challenge 2021. And this is a competition that was held just recently, finished just the first phase recently, and 40 universities from around the world participated in this competition. Some of them just dropped out gradually during the last year. We entered this during the Corona year, which was very difficult, but nevertheless, we actually stayed up all the way to the end of the first phase of the competition, which was the simulation phase. And at the end of the talk, I will show you a video from that simulation phase. We actually reached, I think that we did quite well. Just recently, about 2 weeks ago, they had the final competition, which was with the real car. And the car is what we see here. It's a real race car built, in fact, modified for this to be autonomous. And actually quite disappointing, a little bit disappointing. I was predicting it, but it was disappointing that the last competition was with one car running around the track over 2 laps. And they measured the time, and that was it. Where in the simulation race, of course, it was much more challenging, and we'll see this at the end. So this is just to tease you a little bit to stay all the way to the end of the talk. Just a second, what is it? Yeah. Now, many think, the young guys here probably think that autonomous vehicles started with Mobileye just 17 years or 20 years ago. That's not exactly true. My first paper I published on this subject in 1991, when I was at that time at UCLA, and I was lucky to participate in this project, which eventually was called Demo 97 San Diego. So in 1997, they demonstrated platoons, meaning cars driving or running one after the other, running autonomously over a road. And the idea was to run them in this way so that they can increase the capacity of existing highways, so that they can increase the capacity without building new highways. So this was the challenge. I got some money from that project. And at the bottom, we actually see 3 pictures that I took by myself with my camera. And we can see on the left the car actually leaving the platoon. Then, of course, the driver raises his hand, so we can see that he's not touching the wheel. And on the right, we see that the car is actually challenged with avoiding a few obstacles. By today's standards, this is quite trivial compared to what current autonomous vehicles can do. But that was about 20-something years ago. Okay, just for all of us to remember. Now, speaking of autonomous vehicles, of course, we have these 5 levels determined or defined by SAE. And we are all interested in level 5. And what does it say? Just 2 sentences. It says that it has the vehicle has to perform all driving functions, and it has to do it under all conditions. Quite challenging, not so easy to do. Definitely humans cannot do it as well as we hope autonomous vehicles will do. And what does it mean, driving functions? situational awareness. Sensing is only part of that. Now, I apologize because this session is about sensing. I am not a sensing guy. I am a mechanical engineer. So we are interested in the complementing fields or subject that complement sensing. So sensing is one thing that we need to address. Evaluation of dynamic stability, or actually understanding the dynamics of the vehicle in its surroundings. I think that's extremely important, because without that, you may know that there's an obstacle ahead of you, but you don't know what to do with it. We have to understand what to do with it. We have to understand if we are in danger or not, and this will determine what we do next. And of course, we have to evaluate the solution space, meaning, do we have a solution that avoids the obstacles or not? If we, in a minute, I will just show you what does it mean to understand this or not. But this is something that we have to understand, and I call this situational awareness. I was hoping that the Avatar Magad or consortium will address these issues, but they decided just to focus on sensing, and I couldn't get into this. Of course, we want to navigate to the goal, and we have to select a good path, not necessarily optimal. We have to monitor or regulate our speed. We have to steer dynamically. And when I say dynamic steering, that means that the steering angle is a function of speed. The higher the speed, you may even turn the wheel opposite to what you turn it at low speeds. We have to understand that. We try to in our research. And of course, we want to avoid collision. So all of that is what I call navigate to the goal. This is not comprehensive. This is kind of pinpointing the main issues. And if we are about to collide with any vehicle, of course, we have to plan and execute a safe emergency maneuver. That's a challenge by itself. And all conditions. On the left, we see a road full of potholes. Actually, I was talking to a reporter, an Italian reporter earlier, and he said, "Oh, these are all the roads in Israel." I said, "No, not necessarily." But definitely we have quite a few of those. And this is definitely a challenge to the sensing. You don't want to sense only, you shouldn't sense only the vehicles ahead, but also you have to have somewhat a three-dimensional map of what's ahead of you, because this will determine at what speed you are actually driving over that road without harming yourself or others. And on the right, of course, we see snow. This is a very difficult situation. I don't know what to do with it, but you guys, you should be able to handle it, of course. And question is, do we expect the autonomous vehicle to handle all conditions? And what we see here on the left, actually both pictures, this is a road that collapsed during the Northridge earthquake in 1994 in Los Angeles. I was living at that time nearby, like 10 kilometers north of that. And this lucky guy, he detected the collapse of the road, stopped just in time. And on the right, we see, this is the guy, this is the driver, and he looks at how they pull off the truck off the road. This is a very, very severe situation, very extreme. Question is, will autonomous cars be able to detect and behave accordingly? Now, the challenge is, the way I see it, and this is very, again, not comprehensive, very, very general. So if we talk about sensing under extreme conditions, of course, we have to address all weather, real-time mapping, as we saw earlier. That's very important. There was some time until Mobileye started talking about this, just say 10 years ago. Nobody cared about mapping. My original work was on off-road motion planning. And mapping is everything in moving over off-road. And when I talked to Mafat, they said, "Oh, no, your algorithm is not good because you have to have a good map." I said, okay, I don't want to say, but that's like the Gashash will say, "Astikne idiot, go and buy it, make it." So if you want to move at high speed or in some challenging terrain, you have to get a good map. Without a good map, of course, you can move slowly, but that's not what we are faced with, we are challenged with. Mixed congested, real-time mapping, of course, mixed congested traffic. So in the urban areas, you have cars, you have dogs, you have children, you have elderly people. It's a very difficult task, again, for the sensing people, but we as motion planners, we need good information about all of that. We actually need not only the information about the place of all these obstacles, but also about the speed or velocity of each obstacle in our surrounding. Situational awareness, as I said earlier, this is still, I believe, a challenge. And you want to know how to drive under these extreme conditions. This is something that this competition that I just mentioned earlier, that's exactly their challenge, or that's their task, is to push autonomous driving to the extreme. If you know how to drive at the extreme, of course, you may be able to handle these extreme situations. And of course, you want to be able to make decisions with an empty solution space, meaning that no matter what you do, somebody is going to be hurt. What do you do then? We have to resolve this issue, and we do have one approach for that. We haven't published it yet, but basically this is an ethics dilemma, and actually there are two ways of looking at it, or approaching it. One on the left is, I would say, the utility approach, meaning what costs you less, meaning where you lose less money. On the right, the deontology is what is more moral. So the left one talks about money, the right one talks about lives, and I'm not sure what's the good answer. We have an approach that somewhat merges between the two. Just to point out some challenging issue. And speaking about academia and industry, by the way, I prefer to call it academia and not academy. Academy is more like an institution. Academia is the whole thing. So in academia, as was actually said before, I'm saying it the same thing, but in fewer words, is in academia, we know how to educate. That's our job. We know how to do, should know, not everybody knows, but you should know how to do research. And one thing that is very important is that we should be able to think freely, because we are not bound by how much money we make with our thinking, but we are not bound at all. If you think about something new, this is your duty in academia to do that, as opposed to industry, where everything they do has to end up with how much do we make from their thinking. So these are the things that academia can offer. And of course, industry, was said before, they know what to do, what applications to apply this technology to. And they know because they know where the money is coming from. So that's something we should definitely listen to them. So if we don't know which direction to go, they are definitely the right guidance, the right guide to guide us. They do engineering. We in academia do very little engineering. We do research, we do abstract things, but engineering is just putting a few engineers and actually doing the drawings and making the things run. That's not our duty. Testing. In industry, they cannot sell anything unless you test it. So if they develop an autonomous vehicle or some sensing system, they have to test it, and they put a lot of money into doing this, something that we in academia cannot. We, for example, I've developed algorithms for a long time. I never had a vehicle to test them on. And until recently, where you actually we developed something that is close to that, but this autonomous challenge where they give you the vehicle and you just put the software. That's something that we have extreme difficult time with, is to have the testing facilities, something that the industry, they must have in order to promote the products. And of course, they have a working products where ours may work, may not. It's not our problem, okay? I'm saying it honestly, that's really, we are trying our best, but we are not responsible for everything. Industry has to be. And what can we do in order to encourage this cooperation between industry and academia? So in academia, we definitely have to rethink our educational programs. Right now in Ariel University, we have a nice mechatronics program, but it doesn't push into autonomous vehicles, something that we have to think it over and maybe add some courses to make it more modern and adaptable or fitting to what the industry is interested in right now. We have to expand to the entire spectrum of autonomous vehicles and get out of just sensing something like in the wording today, no sensing, not interesting. No sensing, no מעניין. No, we have to do more. Because with only sensing, it's, you will just address one niche of the problem. And in fact, I heard shortly today Professor Allon and he rose the question, I didn't hear the answer there, but he rose the question, should we be very specific on one thing or should we cover the entire spectrum? I couldn't understand what his answer was. I believe that we should cover the entire spectrum if we want to build a good, strong industry for autonomous vehicles in Israel, and not say something that I heard it before, is that we can develop software, we are not good at hardware. Meaning, buy cars or hardware from somewhere else, meaning mechanical hardware, and you just do the software. This doesn't work. In robotics is actually even dangerous because many times the robot is smart thanks to the hardware that you use. And that's something that I think we should focus on. And of course, we at the university, we want to motivate students. And there are two ways to motivate them. One is written here, is give them something exciting like an international competition. We did that. Because of the corona, it wasn't that successful, even though the results were good. We are now going after it again. So we are restarting a similar project for this year. But the other thing that is not written here, we want to give them hope that there's a job at the end of the tunnel. So if they come into a field, there's industry waiting for them. And I heard too many times, I'm talking now about robotics, that, okay, why do I want to study robotics if there's no industry out there waiting for me? We don't want this to happen in the autonomous vehicle industry. So we have to make sure that there's a connection between industry and these graduates. What the industry can do, of course, reach out to academia and not think, and I felt it sometimes, that the industry thinks, people from industry think that they know it all. They know a lot, actually, but not everything. So they have to reach out and actually check the teaching and research programs and see what can fit them and even influence these directions of teaching and research. Join mentoring. Right now, I'm looking for some mentors, few mentors to mentor this group of autonomous vehicles. And definitely the industry is perfect to provide these mentors. So in fact, some industry are interested, but we have to restart this interest because kind of it died out a little bit. And when they come in, they can definitely help in mentoring the students, but also they can identify the best students that we have. And I'm saying we is academia at large, and sometimes we have extremely good students, and if you recognize them early on, you have a very good person to work in your company. And in fact, I'm trying to keep them away from the industry because we lose them too soon. I have a very good student who is with me here today, and he's a blessing to any place that he is going to join. Of course, we cannot go to the international competitions by ourselves. We do need both financial support and technical support. And I mentioned earlier engineering. For example, one reason that we bailed out of this competition and we didn't go to the actual car is that it needed a lot of engineering that we don't have. We don't have the engineers. We cannot pay for these engineers. Industry, they have them by default, and they can lend them a few months a year or whatever, 1 week, 1 day a week, and we can go together to this kind of challenge. And of course, they have the training and research infrastructure. They can help us in providing us or lending us so that we don't stay only with simulations and do something more realistic. We don't just talk, we also shoot. And this is a project that we developed about 4 or 5 years ago. This was long before the corona pandemic. And this is an autonomous, supposed to be autonomous. We didn't really focus so much on the autonomy, but this is a vehicle that is meant to take the grandparents from their home to the theater or to the concert. And actually, the picture was taken in Abima, where this conference was held a few years ago over there. And the idea was that this car is built for 2 people. It can park perpendicular to the sidewalk. The front door opens up. so that you can walk in and walk out of the door without having to struggle with the way that you get into normal cars. And also to help you even stand up, the seat itself is kind of pushing and raising itself up, so it's easier for these elderly people to actually get out of the car. I haven't seen many think about the elderly the way this project actually thinks about. When the pandemic struck, I realized, actually this is not the only project that we did for the elderly, but I realized that we kind of predicted the future. Because during the pandemic, people were stuck in their homes, in their nursing homes, not being able to get out. And if you wanted to get out, either a stranger would drive you there, or you would take a taxi, and there's no, of course, there's no, even if there's a Uber taxi, it's not easy to get in. So this is a perfect car. Hopefully, I hope that it was actually ready for use, but if it was ready for use, the elderly couple would just get into the car, go around town, even during the close down or the shutdown, what do you call it? Lockdown, during the lockdown, and come back home without meeting any stranger. And that was the key to actually surviving this pandemic, but they didn't have this tool. So this is actually a solution that we developed ahead of time, and I do believe if there's anybody from the industry that we should actually do it even more. And we definitely, I think that we accomplished, it's quite an accomplishment to be, say, third or sixth, depends how you count, place in an international competition. This is like getting the Arad, how do you call Arad in English? The bronze medal in an Olympic competition, and I think we shouldn't stop here. We should continue, and of course, we may not be able to continue by ourselves. So I definitely want to use this platform, this forum, to also the video, whoever sees the video, that we are looking for sponsors to help us actually get back to the competition and do it like big guys. And I don't see this is, actually, in fact, we started it by a personal invitation from the organizers to me, and I saw that from the very beginning, after talking even to Tchiya, I don't see this as an Ariel University participation. I see this as a national competition, or national group, or national team that has to compete as Israel, not just as Ariel. Of course, it didn't work out this time. I hope that it will work out the next time around. And by the way, just to finish this, in January 2022, they are going to compete again, because they didn't really finish the job. They are going to compete again in Las Vegas. And this time they promise to have what's called head-to-head competition, meaning several cars on the road. And hopefully they will repeat this competition for next time, October 2022. That's my talk. Thank you very much. And you have the email to send your interest in sponsoring and mentoring, whatever you want, and I will be glad to respond. Thank you very much.